Hello there and welcome to another Ginger Mathematician video where I'm going to go through my key trigger words to really help you with your iGCSE maths exams. So by recognizing these words and seeing exactly what formula that you need, this should get you those extra 2, 3, 4 marks that might make the difference between that B to A grade or even A to A star grade. So let's get started. My first phrase is exterior angle. So if you see that phrase in a question, you need to think about the following formula. That is 360, so that's a full turn, divided by the number of sides of the shape. So if you see exterior angle and they ask you for that, then you need to think about this formula you see in front of you, 360 divided by the number of sides of the shape. Now, let me show you a question where this has actually appeared. So you're given here a regular polygon, has 30 sides, and then find the size of one exterior angle. And just by seeing this trigger word, this exterior angle, suddenly this 2-mark question becomes 2 marks in the bag. So all we need to do here is just then do 360 divided by the number of sides. Notice we have 30 in this case, and then just work this out. Now, of course, we could use a calculator or a calculator paper. If it isn't, then we can cancel the zeros, giving us 36 over 3. And if we do 36 divided by 3, that then gives us 12. So one angle is going to be equal to 12 degrees. You can see the mark scheme here, and you get that method mark for the calculation I just wrote down here. And this could be the 2 marks you really need. My next term I want to talk about here is factorize, because this comes up a lot on iGCSE exams. And all this word means, is put into brackets. So whenever you see this word factorize, you need to be thinking to yourself, right, put into brackets. Now, let's look at a couple of questions here where this factorizing comes up. I've got a few more handy hints to help you what kind of factorizing you need to do. So let's now look at this typical question. Remember, factorize just means put into brackets. So keep that in mind as we go through the question. Now notice how many terms we have in each question here. So we have 1, 2, 3, 4 terms here, and then we have 1, 2, 3 terms. So both these things tell me that at the end I want to put this into a double bracket. So I count the terms, and that gives me an idea of what kind of factorization I want to do. In this case, into 2 brackets. Now at this point, then we actually look at this factorization procedure. What I would do here is try and put the things that look similar together. So in this case, I'm going to put the 12a x and the plus 3ay together because they look the same, they both share an a. And then I'm going to put the b stuff together, so 2by minus 8bx. Once I've done that, then I can split this down the middle. So I'm going to get a black line here and split this down the middle and then factorize into a single bracket on both sides. So I look at what's in common here. So they have a 3 in common, so 3 goes into both, and we've also got an a. So I can take a 3a out here and then see what's left. So what do I do to 3a to get to 12ax? Well, I times by 4x. What do I do to 3a to get to 3ay? Well, just plus y. And I'm going to do exactly the same process on the other side. So what do these both have in common here? Well, they've both got a minus 2b in common. And then we see, working backwards, what we need to get. So what do you do to minus 2b to get to just a minus 2by? Well, just a y. And this is where you have to be very careful. So what do you do to minus 2b to get to minus 8bx? Well, let's have a think about this. We need an x in here. 2 times 4 is 8. And we need a plus because we want to get a minus at the end. Now notice the brackets are actually the same, just different order. So we've got 4x plus y and y plus 4x. These are the same thing. So we can pop that into our second bracket or first bracket. And whatever's left, so 3a and minus 2b, we put into the other bracket. Now, if I'm in the exam, and that is my answer, 3a minus 2b, 4x plus y, I can always expand the brackets to check that I get back to 7a. With the second question, this is slightly different. So this is a factorizing with a coefficient in front. If you want more detail on this, then do check out the video above. What we know here is we want a 5x squared, so we have to have a 5x and an x here. That's kind of compulsory. Then I look at my last term, minus 8, and think of all the combinations or permutations to give me minus 8. So 4 times minus 2, for example. Again, order matters, so minus 2, 4. Minus 1, 8 also works, 8 minus 1. Again, we can change the signs here as well, so we can have minus 4, 2, 2 minus 4, and the other way around, so 1 minus 8 and minus 8, 1. The way I tend to teach this to my students, because this is quite tricky, particularly if you're revising as AA star questions, is, well, I want to get to a minus 6 here, and I've got a 5. These numbers are quite close to each other, therefore it's probably going to be that these numbers are also going to be close to each other as well. So that helps me identify what I should consider. My next point here is that I want a bigger negative. So I'm going to be looking at where the negatives are. So I'm thinking here 5 times minus 2 is minus 10, plus 4 gives me minus 6. So I'm using a kind of trial and error approach to get the minus 2 here and the plus 4 here. But this is how I zoom in and really think, okay, which combination will probably work. Now, of course, I would check this in the exam, so I would use FOIL or the double eyebrow to expand. So 5x times x is 5x squared. I'm kind of doing this in my head as I try it. 5x times minus 2 is minus 10x. And we've got 4 times x is plus 4x. Then we get the minus 8, so plus 4 times minus 2 is minus 8. Notice these cross terms or middle terms here simplified to minus 6x, which is what I wanted. So I get the final answer, 5x plus 4, x minus 2. Now, I'm not going to go into factorizing in big detail in terms of all the techniques, but the key thing is you see that word, you want to put it into brackets in some form. Sometimes that's a single bracket, sometimes that's a double bracket as well. So you can check the answers that I've gone through here and you can see where you pick up those method marks. Again, this is definitely towards the harder end of the iGCSE syllabus. On to the next part, which is vectors. So we're going to look specifically at the magnitude of a vector. If you see this phrase, all you need to remember is basically Pythagoras. So all you need to think of is magnitude. Right, that means I need to use Pythagoras. Remember, Pythagoras is this equation a squared plus b squared equals c squared. And we can even simplify this further by just remembering this formula of the square root of a squared plus b squared. So that's my thought process when I see magnitude of vector. Often a couple of marks that a student doesn't get. Think Pythagoras, and if you're thinking Pythagoras, remember this formula that I've done down here. So the square root of a squared plus b squared. And this comes up surprisingly often on iGCSE papers. Again, 2 marks that could be lost. So I see this word magnitude. I think to myself, Pythagoras, right, I need to do this. And remember that formula I just gave you with the square root of a squared plus b squared. And all I do is put these numbers in. So my a will be 3, this will be my a, this will be my b. If I put these in and put them in carefully here, so 3 squared plus minus 4 all squared. Again, this is just working through here the procedure. So 3 squared is equal to 9. This is where you need to be really careful. So minus 4 times minus 4 is positive 16. Be really careful at that point. Then we just add those together. So 9 plus 16 is 25. And then the square root of 25 is equal to 5. Remember, a square root is something times something, gives you 25. What is that something? Well, it has to be 5 in order to be correct. Again, you can check the mark scheme here, so you can look through that just to check where you get that method mark as well. My next trigger word is perpendicular bisector. And this is usually a big question, a good 4 or 5 marks, depending on the paper you're doing. And as soon as I see this phrase, perpendicular bisector, this trigger phrase, then I have this step procedure in my mind. First of all, I'm going to find the midpoint of the coordinates that I have. Number 2, I'm going to find the gradient from the line segment that I have. So I've got this process in my mind. Number 3, I'm going to use the m1, m2 equals minus 1 formula to find the perpendicular gradient. And then number 4, I'm going to use the midpoint to find the y-intercept, so to find C. So whenever I see that phrase, this is the thought process going through my mind. Find the midpoint of the two coordinates, find the gradient between the two coordinates, find the perpendicular gradient using this formula or the negative reciprocal. Again, I will go through exam question like this, and then use that midpoint in step 1 to find C. At the moment, that's all seeming quite vague to you probably at home. So let's look at a question where we're going to do exactly that. So this comes from a reasonably recent paper here where we've got the points 2, 8. Now, generally in a question like this, I'm going to write this information in. And we've got the point 6 minus 2 down here. And again, I'm looking for that key phrase, equation of the perpendicular bisector. I'm seeing that phrase, and then I'm going back to my checklist. So number 1, I'm going to find the midpoint. So when I connect these up, so connect this up with a straight line, again, you have a ruler at home, so please do use that. I'm going to find the midpoint of this. So that is my step 1. Now, how do I find the midpoint? Well, the way I tend to do this, there is a formula for this, but what I do with this is if I just get the highlighter out, I'm going to find the 2, I've got the 6. What's halfway between 2 and 6? Well, if you think of it that way, that's just going to be 4. And here, this might be slightly trickier, halfway between 8 and minus 2. If you get stuck here, well, you can always do a number line. So 8, 7, 6, and we can go all the way down to minus 2. Okay, this is why I have this column here to help me with such things. So here's 8, here's minus 2. I want to go halfway between them, and you can use this idea actually to work out the midpoint quite quickly. Well, this is 1, 2, 3, 4, 5 steps. This is 1, 2, 3, 4, 5 steps. So if I do this particular process, I want to go between 8 and then the minus 2, then I'm going to go to 3. You can literally see that this is in the middle of the two numbers. There's a 5 gap here and there's a 5 gap here. So that's how I tend to work at the midpoint. Of course, you can use the formula as well. So that's my stage 1 done. That's stage 1 completed. Number 2 is the gradient. So I want to find the gradient between the 2 points. Again, there is a formula for this. So we have y2 minus y1 over x2 minus x1. Now, what do these things actually mean? Well, let's take this. It's going to be our first point. Again, as long as we're consistent, that's the most important thing. This will be our x1. This will be our y1. Here, this will be our x2. This will be our y2. If we substitute in the formula carefully here, y2 is equal to minus 2. We've got minus, and then we've got an 8 here. So just be very careful with the formula. And then we've got x2 is 6, 6 minus 2. And if we work this out, we get minus 10 at the top here over 4, which we can simplify down, of course. So we divide by 2 top and bottom. We then get minus 5 over 2. So that's my step 2 here. I've worked out the gradient between the 2 points. My step 3 is this gradient of the perpendicular bisector. So perp B gradient. And the way that you do this with a fraction is we're going to flip the fraction. So I'm going to flip this to 2/5, and then we turn it to the different sign. So going from negative to positive. So that's my gradient here. So that's my step 3 done. So I can tick these off as I go. Now we're going to use the midpoint to find C. So what does that mean? Well, I'm going to do this on this slide here, so I've got a bit of room. So this is step 4 here. Well, any line can be written as y equals the gradient, 2/5 x plus c. If we go back, our midpoint was 4, 5. So when x is equal to 4, y is equal to 5. And let's now just substitute that in. So wherever I see a y, I'm going to put a 5. Wherever I see an x, I'm going to put a 4. So we get 2/5 lots of 4 plus c. Again, this is just a little bit of working out here with fractions. So 2 times 4 is 8, so we get 8/5 plus c. Remember, 5 is the same as 15 over, excuse me, 20. Okay, just realised I put the wrong point in here. This is 4, 3. Again, if you notice that at home, really well done. I put the wrong point in, so 3. Again, this is why we always check our answers carefully. It's why I'm leaving it in the video as well. So if you do notice this, you can go back and correct. Something didn't feel right, so we can go back and change it. So this is 3, which is the same as 15 over 5. Keeping it as fractions. And then we want to get the c on its own here. So the opposite of adding 8 over 5 is minusing 8 over 5. And do let me know in the comments if you actually spotted that mistake before I did. So that gives us then 7 over 5 is equal to c. And so our final answer here, now we know c is equal to 7 over 5, is y is equal to 2/5 x plus 7 over 5, which as you can see is the answer at the top. So you can see where the method marks here up on this particular slide. Remember, whenever you see the phrase perpendicular bisector, you need to find the midpoints. You need to find the gradient. You need to find that perpendicular gradient by flipping the fraction and changing the sign. And then lastly, use that midpoint from step 1 to then find the y-intercept, like so. And on to a topic that many students find difficult here, which is variation and proportion. If you want more information about this, more practice on this, then do check out the video above. What I want to talk about is the trigger word here. So if we see varies or we see is proportional to, you need to think about this process. Now, the issue with this, it comes up in slightly different words each and every year. So I'm trying to give you a real good breakdown of how we do this. So if you see y is directly proportional to x, write the following. You write y is proportional to x, so this fish symbol, and therefore y is equal to some constant kx. So if you see that phrase, exactly that phrase there, you need to write what I've written in red. Y is directly proportional to x with the fish symbol, therefore y is equal to kx. If you see y is inversely or inverse proportional to x, then you need to write this. Y is proportional to 1 over x, so that's the difference between direct and inverse, and then that means y is equal to k over x. The issue with this kind of question, the wording can vary quite often. So I'm going through a few examples here so you can see the right trigger words that you need in order to get the right information down. So this one here, y varies inversely, so it's going to come from part 2, as the square of x. How do I write this? Well, I'll go y is inversely proportional, so fraction, and we want the square of x, so x squared. If we translate that into an equation, we get y equals k over x squared, just like that. And again, another variation on this. So y varies directly as x plus 2 all cubed. So y is proportional to, okay, no fraction because it's directly. So we just write down x plus 2 all cubed. If we translate that into an equation, we get y is equal to k lots of x plus 2 all cubed, like so. So with this particular trigger phrase or trigger words, you have to be quite careful exactly which equation you've written down. And my example on the next slide goes through, again, a slightly different wording on the same idea. So this is, again, another iGCSE question here. So P varies. So I've seen that word varies, so I'm thinking about this slide here. Inversely, so I know there's a fraction involved, but this time as the square root of Q. So let's have a think how this works. So we've got P, so remember use the letters that are given here. We've got varies, so proportional, so this fish symbol. Inversely, so that means it's a fraction. And this time the square root of Q. So we write square root of Q. So with our examples here, it's most like this one here, so number 3. So if we look about how we translate this into equation, we replace the proportional symbol with an equals and replace the 1 with a k. So if we go back, therefore p is equal, so replace it, k over root q. Generally, this is the hardest step that students find on this kind of question. Once they have this equation, then it generally goes quite smoothly. So we find k by using the first information. So when q is equal to 9, p is equal to 12. So we get 12 is equal to k over the square root of 9. So 12 is equal to k over 3. Remember, the square root of 9 is 3. And we want the k on its own here. So what's the opposite of dividing by 3? Times by 3 on both sides. 12 times 3 is 36. This cancels, giving us just k. So that's really good. We've actually got an equation we can work with now. So p is equal to 36 over root q. And now we use the second part of the question. So find p when q is 16. So when q is 16, p is equal to 36 over root 16. Well, the square root of 16 is equal to 4. And then 36 divided by 4 gives us our final answer here of 9, like so. Again, to check the mark scheme if you're not sure about that kind of question. Again, these are lots of really useful trigger words that are going to just give you those extra marks where maybe other students don't, those so-called discriminator questions, to make sure you're really happy with the terminology used at iGCSE questions. Now, if you need some help with functions, so you're getting a little bit stuck on functions, you're not entirely sure what kind of questions could be asked, then check out the video right in front of you, because I go through about 50 minutes of all the possible kind of questions that could appear about iGCSE functions.